amazing, isn't it? Take it all in. The views, the lush grass, the air blowing, the wind so peaceful. But no, you're here for databases. Your life is at an end. And now you shall find out the misery, the pain. No, I'm just kidding. You'll be alright. We'll guide you through it. My colleagues and I will get you through this. Just stick around, pay attention, and have a blast with us, eh? Now, I know most of you, life is tough right now, and it's complicated. And I just want to say that things get better. It gets to a point where it's just too much. And that's why I'm going to discuss object-oriented databasing. Just like life is complicated. You had complexity in data. You had complexity in how data is stored and how it is processed. We introduce object-oriented databasing, which facilitates and presents information on the premise of objects. And to do this, objects are divided into two things: attributes and methods. Attributes is data that which defines the characteristics of the object. Just like, yes, you watching this video have an eye color, you have hair, I hope. Some of you may not. Some people are hairy, some people not so much. You know how it goes. And then we get to methods, which defines the behavior of the object in question. So how you run, whether or not you cry while watching a sad movie, whether or not you scream while watching a horror. All of these are actions, all of these are methods. What makes object-oriented so important is, as stated earlier, it facilitates and actually handles complex data and complex relationships. For instance, breakups. No, I'm just kidding. I don't want to touch on touchy subjects here, but let's just continue with that premise. Later on, my colleague will actually go into some relationships and actually conclude data warehousing and all the differencing between some of these databases.
I'm going to be talking about relational databases. Relational databases are based on the relational data model, or how we all know it, the SQL databases. In the SQL database, we have different tables. Each table has a unique name and consists of different columns and rows. Rows are just data about different records, while the columns are different attributes. The different tables are connected through primary and foreign keys. The primary key is a unique value that identifies the table. The foreign key is then just a reference back to the primary key. So if the one table has a primary key and the other table has the matching foreign key, they automatically have a relationship between them. In a relational database, you use the SQL commands to retrieve data from the database. So your wonderful select, inner joins, outer joins, and so on are all based around this database.
Okay, following on what our JP lookalike said, I'll be speaking about the NoSQL databases. A NoSQL database is, well, first of all, it has nothing to do with a rational database, in the sense that it can accommodate a lot of data. It's one of the main new types of databases out there. There is no set model for them. Most of it comes from open source sites. Okay, NoSQL databases do not actually store the relationships in the database. They have to be hard-coded in by the programmer. Most of this is done before everything gets set, so it's a lot more complex to get going. The bottom line of these NoSQL databases is they actually do use SQL, although they are called NoSQL databases. The worst part of it is searching and indexing. In a normal database, you can just use a normal key to search for it. Whereas in a NoSQL database, because of the sparsity of the type of keys, there is no possible search.
So I'm going to explain to you what a data warehouse is.
Well, just move it back.
Okay, so the knowledge father, Bill Emmon, defines data warehouse as an integrated, subject-oriented, time-variant, and non-volatile collection of data to support your decision-making. So this is a very complex term to understand, especially if you've never heard of it before. So let's break down each of these components and compare it to something that we're all very familiar with. So as I said, data warehouses are integrated, meaning they provide a centralized consolidated database that integrates your organizational data and data from multiple sources. Now let's compare this to macro, okay? When you walk into macro, you have your different departments. For example, you have your electronic department and your liquor department, which I'm sure we're all very familiar with. Now, these departments together make up the store macro, and macro provides a house for all these different departments. The second component of data warehouse is that it's subject oriented, meaning that your data is categorized and summarized according to a particular topic to provide answers to any questions you have of a particular business aspect. So think of macro where you have your different employees, okay? These employees have the knowledge of the products in their department so they can answer any questions you have about a particular product. And this can be compared to object-oriented databases. Your object-oriented database tries to be as semantic as possible. Therefore, it facilitates integration and facilitates the achievement of subject orientation because your object is encapsulated with data about a particular topic. The third component is that it's time variant, meaning that your data within your data warehouse refers to the flow of data throughout the history of the company. The fourth component is that it's non-volatile, meaning that once data enters your data warehouse, it is never removed because it refers to the history of your company. This can be compared to your macro card, okay? Your macro card contains information about you as a customer, your personal information, and your previous sales as a customer, and it's never removed from macro systems. So now that we basically understand the basic concepts, we can refer to your more technical aspects of data warehouse. Okay, so data warehouses are implemented by an ETL process known as extraction, transformation, and loading. Okay, your operational database is extracted, it is transformed, meaning it is integrated and filtered, and then it is loaded into your data warehouse. Now, data warehouses are really expensive, they require a lot of time and management. Therefore, it's not unusual for a company to start with something smaller called a data mart. So a data mart is a small single subject data warehouse subset that provides decision support to small groups of people. Your data warehouse is based on the relational database model, and this differs from your NoSQL database, which is not based on your relational database model. The relational database model uses the star schema modeling technique in order to handle multi-dimensional data. Your star schema consists of 4 components. The first component is facts. Your facts basically are your numeric measurements about a particular business activity, for example, sales. The second thing is dimensions. Dimensions are your qualifying characteristics that provide additional perspectives of a given fact. Your third component is an attribute. Your dimensions provide descriptive characteristics about a given fact through their attributes. Your fourth component is your attribute hierarchy. Your attribute hierarchy is a top-down data organization that is used for aggregation, drill down, and roll up data analysis.
Our #1 fans, they can learn databases, you can too. Believe in yourself, believe in your abilities, and you too can not only float on water, but you will soar as well.